both my undergraduate and master's in engineering physics. Initially, I was working more in theoretical physics. The first thing that got me into physics was cosmology, trying to understand the universe, where does the universe come from, all these like big questions that, and that fascinated me a lot. I started working on it, and I realized that I may not be the best suitable person for doing a purely theoretical work. So then, even still in engineering physics, I shifted a bit my focus to more engineering problems. So then I worked in control and data acquisition systems in nuclear fusion. So I worked for a couple of years in management consulting, which has nothing to do with science, because I decided back then that I didn't want to continue that path. It was a very interesting experience. I learned a lot. So all these different experiences, I tried to take the best out of them. I hit moments where I assess whether I'm doing something that I like, and it's not just doing something that I like, where I'm actually doing what makes most sense for me to be doing at the time. For sometimes I've come to realize that was not the case, and when that happens, I change. And maybe I don't put that much I don't think that hard about where to go next. It's usually, I'm kind of impulsive, so it's something that at the moment seems more attractive, and I end up going to that, even if it means completely changing what I'm doing at the time. So right now I'm studying some mechanisms of motion perception in the cortex. So for example, some people that have very specific lesions, while they can perceive everything about all the visual information about the world, they can identify objects, they cannot perceive motion. So they have difficulties in, for example, filling a cup, because they can see the liquids that they're putting inside the cup, the different levels, but they don't perceive that the actual liquid flowing into the cup. So motion is a very specific information stream that we extract from the visual world. We train animals to basically to report the direction of a stimulus, of a moving stimulus, and when it's moving in one direction, they do one action. When it's moving in another direction, they do another action. Then we can manipulate neuronal activity, and we can also record and try to identify which parts of in the cortex, that's the part of the visual system that I'm working on, are involved in this motion processing. So when I come to the lab and I do an experiment, sometimes it works, other times it doesn't work, and many times it doesn't work in a row, and so it's hard to not be certain of the output of our work. The same. So the fact that we don't know if it's going to work, when it works, we can say that we know something very specific, that maybe we are the only people, we are the only person in the world that at the moment is seeing that thing. While having all this uncertainty can be very frustrating and hard to deal with, it also presents this opportunity for learning something new. I like to see what I'm doing as kind of moving the boundaries of our current understanding, of the current knowledge, and so it's very rewarding when something works and we can say, I made this little contribution into basically advancing our current understanding of how the brain works.